to making our bonnet now using machinery. We'll be using 3 different machines. We'll be using our slip rollers or roll formers. We'll also be using our electric bead roller and a panbrake or a folder. Using slip rollers or roll formers will give us a consistent radius. You can also tighten up the radius, for example, through the outer sections of our bonnet. Even making a full-size hot rod bonnet, this is exactly what you would use. So, the first thing we're going to be doing is our center line on the back side, exactly how we did our handmade bonnet. Then we'll start the process by setting the back roller to the depth that we think will be correct. Roll forming, trial fitting, marking, then continue to roll, and we'll tighten up each side of the roller, flip it around so that we're doing symmetrical right to left. When we're using our roll formers, the first thing we'll do is to roll the general profile first. Then, as we did with the handmade one, we'll be marking the tangent where it departs from the radius. We can then reset our back rollers, use our quick release to feed the piece in. Once we've got the right hand or left hand correct, we can then turn it around and make sure we get symmetry left to right as far as our roll or curvature on the bonnet. When setting up our sheet metal slip rollers, what we've got to do is adjust the back stop down so you're opening up the clearance. Then what you have to do is material thickness clearance, which is adjusted from the front through the screw feed. Then when you actually roll it, what it's got to do is pinch, just grab it, not squeeze it and not slip. The pinch point pressure between your rollers should allow a free movement where the piece just basically travels through without grabbing or being too loose. When roll forming, what we've got to do is make sure that we work to a parallel line with our top rollers, not to the outside edge. So the first thing is, these are parallel to each other, then we'll adjust our backstop up. Whether you do it by one complete 360-degree turn equally on both sides, or you measure inside height with a ruler, doesn't matter, as long as they're the same. So, center line to center line again. Wow, look at that. We've already covered probably 60% of the surface area on the back. So now what we've got to do is work our way from the front. So approximately this area here, we'll draw a line from here where it departs from the forming buck. We can then project a line across the back here, again where it departs from the forming buck. From there to there, we can then tighten up our rolls, roll that, remove the quick release, flip it around, do the same on the other side. Because we do this process upside down, I'll have to transfer those marks to the underside so that we can clearly see where we're rolling and where we have to stop. Again, with our slip rollers, you can see here we've rolled the center and it's fitting the forming buck really well. However, now we have to tighten up the front radius. On the back, we're spreading it out further apart, so therefore you can see that this is tapered. We have to keep this line parallel with our rollers, so we're going to be feeding the piece in at an angle now. Right, so the next point, what I've got to do is adjust our back roller up. Then when we've adjusted our back roller up tighter again, just by 5 millimeters, what we then have to do is when this line gets to about the middle of the top roll, we stop and we can remove it. Our pencil line is now directly underneath the top roller. So I can reverse it, or you can release some back pressure, quick release, and come out. So the front's going really well. The back, literally all we have to do is just a little bit of pressure, just get these sides to spring out a little bit. Yep. We've got the bonnet fitting the buck now really well. There's a little transition area from one radius to another. How we go about smoothing that is using a little 1-inch wheeling machine, and we'll smooth or blend that transition out. When wheeling this particular part, I'd like to use a 1-inch wide machine. However, a 2-inch wide machine is still suitable because it will still fit within the physical dimensions of this part. A 3-inch wide machine may be too wide for this piece. So we've got 3 different radiuses. The outer part here is a 2.5-inch wide radius. Then through the middle, this section in here, that's a 5-inch radius. Through the center is a 12-inch radius. When selecting your radiuses, you need to make sure your point of contact is directly through the middle lower anvil. If you use too flat a radius on a very high crown, what will happen is you'll leave edge marks or ridges in the piece. Okay, and you can just barely see faint little lines. They're called tracking lines from start to finish. Now right here is where we're going to do our transition to the 5-inch radius, and we're going to be doing that in this area. Just a tiny little bit of pressure. We're not looking at really putting a heavy compound curve into this. All we're looking at doing is just blending. Always keep your tracking lines as close as you possibly can. Try not to overlap each other. Always have a slight gap between the two, just a few millimeters. Now we've done our rolling, our wheeling. I just need to take a little bit of this roll out of the very bottom edge, right from our fold point, where the bonnet becomes vertical, both sides, front and rear. We do that by putting it in the panbrake, then a little sacrificial piece on top, so that we don't leave any marks or pressings in this section here that we'll be suaging later. We've removed our lower extension blade so that I can get the piece right in as close as possible to the jaws or the panbrakes. Also, I've marked just with a pencil the fold point here at the front and at the back. I've then orientated it with the vertical face of the lower blade, because then what we're doing is we're using our sacrificial piece of steel here that will clamp down on. So it's just going to flatten it to this point. So don't put that fold line underneath the blade. Sit it level with the front face. Now I'll just do it in 2 stages. So this section here is good, because this blade only has a contact area of about 15 millimeters. So I'm doing it in 2 stages. Just pull it out ever so slightly and then do the next stage. You can just see where it starts to kick it out. And then as you pull it out, if you see any curve or roll, etc., just have that point flattened. So you can see here, this line through here later will be suaging right through there with our electric bead roller. So doing this in 2 stages. Initially, first stage is right on the fold line, level to the front face. Second stage is we're working our way down because the contact area on that blade is only 15 millimeters. now I'm ready to fold this outside edge. This is the section that we have to fold in, which is about 20 degrees. So literally turning this in so it's vertical, right through our fold line here. So it's not a lot of fold. Do it a small bit at a time and then keep checking against your forming buck. Just before I fold, I've transferred the fold lines to the inside face of the bonnet. Again, lining up front and rear, very small fold, so take your time and trial fit. A little bit more. Now we've completed our vertical fold, what we have to do off drawing 23 is measure 25 millimeters up from the bottom line, both front and rear, drawing a straight line. That becomes the middle of our suage. We then will be suaging outwards, so it becomes a male suage line through the center right here. I've set up these 3/8 male-female suaging dies. We've also got the male on the bottom, the female on the top. The reason being is because the job is going to hang down here. Otherwise, if it's up the top, in reverse, it's going to hit the handle. Now, I've also set about 1.5 mil depth on our suage, 25 millimeters deep on our backstop, slow RPM on the speed, and I've done a test piece. On our machine-made bonnet, we're up to folding the bottom flange in. If you've already done the handmade bonnet, then that's done. If you have a magnetic panbrake, that could do it. However, what we're going to do is cut down the center line. On drawing 23, here's our hinge dimensions. So we'll actually be removing 5 millimeters down the center line to allow the bonnet to fit. I'm now ready to mark the 5 millimeters that has to be cut out. On template T25, we had a center line. So measuring 2.5 mil on one side, 2.5 mil on the other, then project that to the rear. So we've got that 5 mil channel. If we're going to be using power tools, cut-off disc, what we'll do is transfer those lines to the inside of the bonnet using some flat bar, set it up, clamp, that then becomes a cutting face, turn it round, we remove the other section from the other half of the bonnet. However, we're going to be using bench-mounted hand shears. I've marked the center line, 2.5 mils on each side, so there's a 5 mil channel that we'll be cutting out. So we'll set it up on the bench shear, then we'll do this in 2 cuts. I've adjusted the stop out of the way so it doesn't interfere with the bonnet. And now I can initiate the first cut. So line of sight is against the shearing edge. We also need to make sure that the end is again line of sight where it's going to be vertically cut. So just make sure you get the orientation correct. You can see here, this is our 5 mil channel that we have to remove. Just setting up to do the bottom fold now, so it's in 10 millimeters. Then we lock it. We've also got a sacrificial piece here where this section would slide up because we're going to have to fold it to the point where this will touch the head of the machine. Get this piece so it's vertical. We've finished folding the bottom edge of our bonnet. We can now move on to the piano hinge. Part number 123, 124 and 125. It's a 305mm long hinge that we purchased from a hardware store for a toy box. It needs to be 26mm wide with a 4mm pin running through it. So we can now go on and start making our part 123 and 125. We're going to make part number 123. We're cutting it out of the end of the piano hinge. This section here is the leftovers that we'll be then trimming the tabs off, and the pin will then be located into the firewall where we drill and insert the tube into the timber firewall. I'll put the hinge in the vise, just a little bit of locking pressure. We need to do 3 cuts. The first cut is just next to the hinge pin. Then we'll be cutting across to relieve or remove this tab. We'll then turn it around and we'll cut the excess off the other side. So we don't want to cut through the pin, and we do want to salvage this little tube. I'm going to use a cut-off disc on a cordless grinder. However, if you're not real sure about this, just use a hand hacksaw. So be very careful when you do this. You've got to be quite accurate. We don't want to damage that pin, and we want to save that tube or sleeve. This is our locator or support tube that's going to go into the firewall. When we drill the hole in the firewall, that's going to be a round hole. This section here, we're just going to run over it with a file just to round it off, because when we drill the round hole, it's got to insert very neatly. I've temporarily vice gripped the radiator shroud to the forming buck because we can now see this area is what we'll be salvaging. This section of the hinge we're going to have to weld together, because if we cut it, this will all fall apart. We then will have 2 holes that we're going to be drilling. We have to then measure 14mm in and cut across. Just clean any paint surface or plating, etc., so that we can weld these 2 faces together. How I'm going to weld it will be MIG tack welding. Now I just need to sand it smooth. Checking drawing 23, we've got to measure and mark in 14mm. Then we've got 2 4mm holes to do 16mm apart. So firstly, we'll center punch our holes, drill, then we can cut it off. Just drilled the 4mm holes. This is the countersunk bolt that we'll be using later on assembly. So the top side, I'm just about to put a little countersink in it, because later on when the bonnet gets fitted, we don't want the bonnet to be pushed up out of position. I've done the drilling and the countersinking. We did it all as one piece because that was quite easy to handle. I can now cut it off, and that will become our bonnet support bracket. The last piece on the support bracket is using a 3mm pin punch. We're going to drive the remains of that hinge pin out. Just checking our drawing again, we need to measure 258mm from the edge of our sheet metal, not the pin. So 258mm, which is back here. We can then, as we initially did, cut in from the end, removing that sheet metal, but do not cut the pin. I've cut away the outside tabs. We've now got this last 8 millimeters where the center of the hinge is, the housing. So what I'm going to do is pull the pin back 25 millimeters, then cut it off, and we'll push the pin back in position. Just to help the process, I've sprayed a little bit of WD-40 on there, vice grip on the end, and pulled it out. So just wiggle it as you do it. We've finished making all the components for our hinge. Now we're going to mark a center line running through the forming buck onto the radiator shroud. We'll then be positioning our front radiator support, marking and drilling 4mm holes to then attach this to the radiator shroud. We can then set up the hinge and trial fit our bonnet halves. When we do the final fitting of our hinge support bracket, we'll be using M4 countersunk screws, nuts and bolts. At the moment, what we're doing is using some small countersunk wood screws, which is good for trial fitting on the forming buck. We'll be fitting our hinge, then our bonnet sides, and that will allow us to then continue and make our bonnet side panels. Now I've got the bonnet hinge sitting in place temporarily on the forming buck. That will allow us to then fit the two bonnet halves. You can see this is how it would actuate. We can then also get good fit and alignment to our radiator shroud and allowing us to fit the side panels that will be louvered.